Well, we proceed forward with our third video in Module 3, where we continue developing the concept of a confidence interval. In this particular module and video, we will actually work a problem to show you how you could develop a confidence interval for a raw data point. Now, confidence, again, is the likelihood that an event will occur. It's represented by the letter C. Error is the likelihood that an event will not occur, and it's represented by alpha. Given levels of confidence can be represented by z-score boundaries, noted as z-confidence, and can be extracted from a table list. You have the table. Use the table. The formula for a general confidence interval, and by general confidence interval I mean a confidence interval for raw data in a population, is C equals, the lower bound is mu minus Z confidence times sigma, and the upper bounds is mu plus Z confidence times sigma. The Z confidence times sigma is known as error E, effect size, and Z confidence times sigma is known as E, the effect size. So mu minus the effect size and mu plus the effect size. You're learning new terms. For a given normal curve, under our formula becomes, Z plus or minus Z confidence times sigma, or mu plus or minus the effect size. The effect size is Z confidence times sigma. Now, identify the problems that you're solving. Identify the things you know, the confidence level, mu and sigma. Find Z confidence based on your confidence level. Go to your table, get that value, and plug these into this value. The lower bounds is mu minus Z confidence times sigma. The upper bounds is mu plus Z confidence times sigma. Now, I told you this isn't very intense. This is not mega algebra. This is simply using formulas and solving for values. Again, here's your confidence interval for critical values for Z. And note that Z confidence is called Z critical value. This is the critical value that you will be looking for to develop your confidence interval. Now here's a sample problem. A manufacturer is producing cups of drinkable fruit juice. The daily production is 10,000 cups, yielding a mean per cup of 189 milliliters and a standard deviation of 5 milliliters. Construct a confidence interval to represent 98% of the cups. So if the intent is 189 milliliters and the standard deviation of what's put in them is 5 milliliters, then what we want to do is know what's the lower bounds for 98% and what's the upper bounds for 98%. Now, in order to do this, you identify the type of problem that you're solving. This is a general data confidence interval. Identify the things that you know, the confidence level, mu and sigma. Find your Z confidence based on your confidence level and plug these into the formula and solve. Not very hard. Step 1, this is a general data confidence interval. In other words, we're developing a confidence interval to look at general data and its distribution. Step 2, we read the formula. The confidence level is 98%. The mean is 189 milliliters. And the standard deviation of 5 milliliters. We're in good shape. Z confidence, we would look at the table. 98% is 2.33. And then we would plug it in. The lower bounds is 189 minus 2.33 times 5. And the upper bounds is 189 plus 2.33 times 5. So we go about solving the problems. We would solve this first. 2.33 times 5 is 11.65. That's your effect size. 189 minus 11.65 and 189 plus 11.65. So the confidence interval that we have says that 98% of the fruit juice cups will be between 177.35 milliliters and 200.65 milliliters. That's pretty good. We know what the confidence level is, and we just simply used our plan. We knew that it was a general data confidence interval. We identified the things you know, the confidence level, mu and sigma. We found Z confidence based on your confidence level using the table. We plugged them into the formula and solved. Nothing hard. The process allows you to describe the distribution of items when you know the confidence level, mu, and sigma. This is nice, very nice. However, we would much rather find the sample mean x bar and standard deviation s to predict the population mean. Remember, I told you that most of the time we don't know the population mean and certainly don't know the population standard deviation. Our concept will be to develop a sample. We're going to find a process where we identify a sample. We take a sample, we find its mean, its standard deviation, and we use that to predict the population mean. This is the real use of confidence levels and confidence intervals, and more good things are yet to come. Keep climbing the ladder. You've got this. I'm very proud of you. You're doing very well.